Today we're going to do an example of Gaussian elimination. So I'm going to start with this 3x5 matrix, and we're going to do the forward steps and the backward steps to get a reduced row echelon form of this matrix. So let's start with the forward steps. Now the forward steps, our goal is to get the leading ones and then zeros below them. So the first thing we're going to do is I'm going to focus on this first element, and I want to make this a 1. So to do that, I'm going to do 1/2 row 1, and I'm going to replace row 1 by that. So I'll get 1, 1, 2, 2, 3, and then the other two rows, I haven't changed anything about them yet, so they'll just stay the same. Okay, now I want to make the numbers below that leading one that I just obtained, I want to make these numbers 0. So I'm going to start off by making this number 0. Okay. Now one thing I want to point out is that we are working right now in the first column. So we want to use the leading one in that column to carry out the rest of our steps. So I'm going to use the first row to make those zeros below the leading one appear in my matrix. So I'm going to do minus row 1 plus row 2, and I'm going to replace row 2 by that. So that will give me, I'll have the same top row. My second row now becomes 0, 1, 4, 1, 0, and my bottom row stays the same. Okay. So we have successfully turned that into a 0. Now our next step is we want to make this last element down here in the first column 0 as well. And again, because we are working in the first column, I'm going to use the leading one in that column. So I'm going to do minus row 1 plus row 3. I'm going to replace row 3 by that. So my first two rows stay the same. 0, 1, 4, 1, 0. And my last row becomes 0, negative 2, 0, negative 1, negative 2. And that's from doing minus row 1 plus row 3. Okay. So we have successfully completed the forward steps for this first column. Now we're going to move on to the second column. The leading one that we want to get is here, and it's already a 1, so we don't have to do anything at that point. So our next step would have been to turn this into a 1, but because it's already a 1, we're good to go there. So now our next step is going to be to look at the number below that. So we want to turn this into a 0. Okay. Just like in the last few steps, we're now in the second column. So I want to use the leading one in that column to do my next Gaussian elimination step. That means I'm going to use row 2, because that's where my leading one is. So I'm going to do 2 times row 2 plus row 3 and replace row 3 by that. And that leaves me with the same row 1 that I had earlier, the same row 2, because I haven't changed row 2 anyway. And then our third row is going to end up being 0, 0, 8, 1, negative 2. All right. So we got our 0. So we have our leading one and our 0 in the second column. We're not going to worry about this 1 yet until we do the backwards steps. So we're going to continue on to the third column, and the leading one that'll be in this column is down here. So what we need to do in this next step is make this element a 1. Okay, so to do that, we just need to do 1/8 row 3 and replace row 3 by that. So we'll get 1, 1, 2, 2, 3, 0, 1, 4, 1, 0, and then 0, 0, 1, 1/8. Write it a little neater, 1/8, minus 1/4. or negative 1/4, sorry. That's its own element there. All right, this has completed the forward steps. We got our leading ones and we got the zeros below them. That was the goal of the forward steps. Now we're going to move on to the backward steps. Backward steps. And from here, we're going to go from right to left, and we're going to try to get zeros above the leading ones. So these elements here. So our goal, we're going to start from right to left, so we're going to start in the rightmost column that has a leading one in it, which happens to be the third column in this case. And our goal now is going to be, we first want to make this element a 0. Okay. Now that we're in the third column, we want to use the leading one in that column to complete our tasks. So we're going to use the third row because that's where the leading one in that column is. So I'm going to do -4 row 3 plus row 2 into row 2. And that's going to leave me with 1, 1, 2, 2, 3. And the next row will become 0, 1, 0, 1/2, 1. And then the third row stays the same. Okay, the reason that we want to use the row that contains the leading one is because there are zeros there that will leave our other leading ones alone. So these zeros will make sure that we don't affect the other two leading ones, so that we're not creating elements that are non-zero in places that we don't want them. Okay, so that's why we're always going to use the rows that have the leading one in them. So our next step is to make this 2 a 0. That's our next goal here. And again, we're still in the third column, where our leading one is in the third row. So we're going to use the third row to make this happen. We're going to do -2 row 3 plus row 1 into row 1. That'll leave us with 1, 1, 0, 7/4, 7/2. And then our second row stays the same as it was. And our third row also stays the same as it was in the previous step. Okay, so we have successfully changed this column. We have a leading one with zeros above it. Now we want to take care of this 1 here, because in the second column we have a leading one and we need a 0 above it as well. So our next step is to make this a 0. Okay. And the way we're going to do that is we're going to notice that we're in the second column. Our leading one in that column is in row 2. So we're going to use row 2 to make this happen. I'm going to do minus row 2 plus row 1 and replace row 1 by that. Give myself a little space here. That leaves me with 1, 0, 0. 5/4, 5/2, 0, 1, 0, 1/2, 1, 0, 0, 1, 1/8, -1/4. And that is our answer. That is our matrix in reduced row echelon form. I hope this helps clear things up. Notice that I have all these numbers on the right here. They actually don't really have an effect on whether or not our answer is in reduced row echelon form, because all we care about is that the leading ones are to the right of the ones above them, and that they are the first non-zero entry in each row, and that all of the elements in those columns besides the leading ones are 0. Okay, so I hope this was helpful, and let me know if you have any further questions.